Okay, one common application to exponential functions is compound interest. And we have two formulas here. One formula is compounded n times a year, and the other formula is for compounded continuously. Now, in both formulas, P represents your principal, R represents your interest rate, but remember, when you do your calculations, you have to put it in a decimal form. So if the interest rate was 1.5%, you would want to input it into your equation as 0.015. Your N is the number of times it's compounded per year. So for example, if it says the bank compounds something semi-annually, that means it's compounded twice a year, and N would be 2. Another example would be if the bank says it compounds something monthly, that would be 12 times a year. Or another common one would be quarterly, that would be 4 times a year. T is your time. So whether you're in years, usually it's in years, but T is going to be your time unit. Okay, so looking at the compounded n times a year. So if you look at this, P is what's in front, so that's going to be my initial value. That's like my y-intercept. And my growth factor is the 1 plus r over n, and that tells me how fast it grows. That's my base of my exponential function, which is why it's related to the rate that's given. For compounded continuously, notice that we have in the formula E. So if you're using the compound interest formula, you want to use that E function on your calculator. So in example 1, it says, after a certain amount of years, the value of an investment account is represented by the equation A of t is equal to 12,750 times 1 plus 0.04 over 6 raised to the 60. Your A of t, I didn't mention this yet, but your A of t is what's called your accumulated amount. So for example, if I put $10, just for a nice simple example, if I put $10 into my bank account and I earned $1 in interest, at the end of that month, my accumulated balance would be $11 because it's whatever I had in there previously plus my interest. So that is the accumulated amount. Okay, so in part A it says, rounded to the nearest cent, what is the value of the account? So what we want to do is plug this into our calculator and figure out what we would have in the account if that represented the amount of money we had in there. So in the calculator, this is how I'm going to put it in, 12,750. Then I'm going to put parentheses, and then I'm going to put 1 plus 0.04 divided by 6, close parentheses. And then I use my little caret symbol to raise it up into the exponent. And then I put 60. When we do that, we would get $18,995.53. So this is the accumulated amount of money that is now in the account. Okay, part B says, what is the initial deposit made to the account? Well, we can get that information just by looking at the formula. Our P is our principal, which is our initial value, or initial amount. And so that is this value right here in the formula. So my initial amount that would have been put in the bank would be $12,750. $750. Now, if I want to add on a second part to this question, since this is the amount that was initially deposited, and the $18,995 is how much I have at the end of this time frame, then if I want to figure out how much interest I have, I would just subtract the two. So if I wanted to find interest, I would take the 18,995.53 and subtract the additional or the initial amount, and whatever's left over is the money that was given to me by the bank for interest. So that, when I subtract that, I would get 6245.53. So this would be the interest. Just like if I said I had $11 left in my account at the end of the month and I originally deposited $10, what's the extra stuff that's in there would have to be the interest. Okay, how many years had the account been accumulating interest? So that we can tell by our exponent. If I look at the exponent of this formula, the exponent is 60. And if I look at the formula, the general form before you plug values in, it's n times t. That 60 represents n times t. And so if you notice, first we need to figure out what n is, because once we know what n is, then we'll be able to figure out what t is, because n times t has to give me 60. And t represents the number of years. So in the formula down here also, underneath the r, I have my n by itself. So I know my n is 6, which means my t would have to be 10, because 6 times 10 would give me the 60. So this would have to be 10 years, because 6 times 10 would give me 60, right? Because this is n, so this would have to be t to get me n times t in my exponent. Okay, next example, it says an account is opened with an initial deposit of $6,500 and earns 3.6% interest compounded semi-annually. Round all answers to the nearest dollar. So when we're done, we have to make sure that we round to the nearest dollar. Okay, so because it says it's not compounded continuously, it's compounded a certain number of times a year. So that means we're going to use this formula here. There's two formulas. One's compounded continuously, one's not compounded continuously. If it's not compounded continuously, we are going to use this formula here. Okay, it's asking what will the account be worth in 10 years? So we're looking for the accumulated value. We're looking for our A of t. So I need to find what my principal is so I can plug that in. Our principal is our starting amount. So that would be $6,500. And then our formula is 1 plus R. R is our rate, which is the 3.6%. But when we put it into our formula, we have to make sure we put it as a decimal. So we're going to put it in as 0.036. And then we got to divide that by n. N is the number of times it's compounded a year. And in the problem, it says it's compounded semi-annually. That means twice a year. So n is going to be 2. And then we're going to raise this to the power of n times t. So since n is 2, and the number of years this would be is for 10, I would have 2 times 10 in my exponent. So when I go to put this in on my calculator, I want to put in the 6,500, then parentheses 1 plus 0.036 divided by 2. And then I want to raise it to the power of, now you can either put in 20 and just do the arithmetic yourself, put it in just a 20. Or if you want to put it in as multiplication, make sure you put parentheses around it so the calculator knows that you're raising the power to 2 and 10 and not just the 2. Okay, when you do that, you're going to get, when you put that in your calculator, 9,000. $286.86. Now it says round to the nearest dollar, so my final answer, if this was on your online homework, I would put it in as $9,287. Okay, what if the interest was compounded monthly? So if it's compounded monthly, all that's going to do is change my value of n. Instead of doing it twice a year, we're going to do it monthly now. So my formula is going to be virtually the same, but instead I'm going to change that 2 to a 12. So I'm going to put it in like this now. Instead of n being 2, it's going to be 12 now because it's compounded monthly. And then in my exponent, I'm going to have 12 times 10. So when we put that in on the calculator, just remember, if you put it in, you can do the arithmetic yourself and just put in that the exponent is 120, if you can do that in your head, 12 times 10 real quick. Or if you put the 12 and the 10 in the exponent, make sure you put parentheses around it. Okay, so when you put that in your calculator, you should get $9,311.62. Now, since the problem says round to the nearest dollar, if this was on your online homework, you should put it in as 9312. Okay, what if the interest was compounded daily? Then same thing again. The only thing that changes is the number of times it's compounded a year, which would be our n. So we're going to assume we're not going to worry about the leap year and the extra quarter of a day. We're just going to round it to 365 days, and we're going to put in n as 365. So I'm going to put in a of t. My accumulated amount is going to be 6,500 plus 0.036 over 365. And that's going to be raised to the power of 365 times 10. And when we do that, we're going to get $9,316.48. Now, if this was your online homework, you want to make sure you follow the directions so you can get credit. So make sure for your final answer, if this was your online homework, make sure you put it in as $9,316 because you have to round to the nearest dollar.